Radioactivity, one of the most fascinating and misunderstood phenomena in the natural world. From powering our homes to treating cancer and even shaping the very earth we live on, radioactivity plays a vital role in science and society. But what exactly is radioactivity? How does it work? And why does it matter? Welcome to Grossdenken, my friends. In this video we'll break it all down in simple terms, backed by real science. And please support this science channel grow by subscribing. Let's dive into the world of radioactivity. To understand radioactivity, let's start with the basics of an atom. Atoms are the building blocks of everything in the universe. They consist of a nucleus made of protons and neutrons, electrons which orbit around the nucleus. Radioactivity happens when the nucleus of an atom is unstable. Instead of staying intact, the nucleus releases energy in the form of particles or electromagnetic waves to become more stable. This process is called radioactive decay. In simple terms, radioactivity is the spontaneous emission of energy from unstable atomic nuclei. There are three main types of radioactive decay, and each releases a different kind of radiation. Alpha decay, so the nucleus emits an alpha particle, which consists of 2 protons and 2 neutrons. Alpha radiation is heavy and slow, and it can be stopped by something as thin as a piece of paper. Beta decay. The nucleus emits a beta particle, which is either an electron or a positron, a particle like an electron but with a positive charge. Beta radiation is faster and more penetrating than alpha radiation, but it can be stopped by a sheet of aluminum. Gamma decay. The nucleus releases gamma rays, which are high-energy electromagnetic waves. Gamma radiation is the most penetrating and requires thick lead or concrete to block it. These types of radiation differ in strength and how they interact with matter, making them useful in different applications. Radioactivity occurs naturally in some elements because their nuclei are unstable. For example, uranium, radium, and thorium are naturally radioactive elements found in the Earth's crust. Even common materials like bananas contain small amounts of radioactive potassium-40. But why are some nuclei unstable? It comes down to the balance between protons and neutrons. If the ratio is off, the nucleus becomes unstable and starts decaying. Radioactivity can also be artificially created. Scientists can bombard stable atoms with high-energy particles to make them radioactive. This is how we produce isotopes used in medicine and research. So, radioactivity often gets a bad reputation because of its association with nuclear disasters and radiation sickness. But is it always dangerous? Well, the answer really depends on 2 factors: the type and energy of radiation, and the dose you're exposed to. For example, alpha radiation is actually harmless if it stays outside the body, but it becomes dangerous if it's inhaled or ingested. Gamma radiation, on the other hand, can penetrate deep into tissues and is more harmful. Now, when it comes to the dose of radiation, low levels, like what you get from natural sources or medical X-rays, are generally safe. But high doses can damage cells and DNA, leading to radiation sickness or even cancer. That's why, radiation safety involves using shielding, keeping your distance, and minimizing how much time you're exposed. Despite its risks, radioactivity actually has countless benefits and applications that shape modern life. For example, nuclear energy uses radioactive uranium in reactors to generate electricity, providing a low-carbon energy source. In medicine, radioactive isotopes are used in cancer treatments, like radiation therapy, to target and destroy tumors. They're also used in diagnostic imaging, such as PET scans, to help detect diseases. Scientists use radioactive carbon-14 for carbon dating, which lets them determine the age of ancient artifacts and fossils, giving us a window into the past. Radioactive materials are also super important in scientific research, helping us study everything from the structure of atoms to the origins of the universe. And in industry, radioactivity is used for inspecting welds in pipelines, sterilizing medical equipment, and even in smoke detectors. Honestly, without radioactivity, many of these advancements just wouldn't be possible. You know, radioactivity isn't just a human-made phenomenon, it's actually all around us in nature. For example, cosmic rays, which are these high-energy particles from space, are constantly bombarding Earth, and they contribute to our natural background radiation. Then, there's the Earth's interior. Radioactive decay of elements like uranium and thorium generates heat, and that heat actually drives processes like volcanic eruptions and plate tectonics. Oh, and don't forget about radon gas, which is a radioactive gas naturally emitted from the ground, and it can build up in poorly ventilated spaces. While these sources are usually harmless, they're a good reminder that radioactivity is just a natural part of our world. Alright, let's clear up some common misconceptions about radioactivity. First off, not all radiation is dangerous. The radiation from your microwave or smartphone is non-ionizing and totally different from radioactive decay. Also, radioactive materials don't actually glow green. While some radioactive substances can emit light, that glowing green you see in pop culture is honestly just an exaggeration. And here's something interesting: radiation is everywhere. You're exposed to small amounts of natural radiation every single day, whether it's from the sun, the ground, or even the food you eat. Understanding the science behind radioactivity really helps us separate fact from fear. Radioactivity is honestly one of the most powerful and fascinating forces in nature. While it definitely has its dangers, it also holds some incredible potential to improve our lives and expand our understanding of the universe. From powering cities to saving lives, radioactivity is a reminder of the dual nature of science. It can be both destructive and transformative, depending on how we use it. So, what do you think about radioactivity? Does it scare you or inspire you? Let us know in the comments below. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more science content. Until next time, stay curious.